Hello, everyone. Oops, there's that recording signal. So the recording is on, and I'm here. And welcome to the virtual night sky, our version for December the 1st, 2021. We've made it all the way to the end of the year, the last month of the year. We've got lots of stuff to talk about tonight. First and foremost, I'm just going to announce from the get-go, tonight's program is going to just run a little bit differently than the rest of them you've been watching and getting to know over the years. We're going to ask some questions in the middle and at the wrong times. We're going to actually end. We're going to do some current events in the middle. We're going to end with a real special presentation about the 10 things that we're looking forward to going into 2022. With me tonight is Kim Baptista. She is our webmaster. You know her from the communication that she's gotten you to kind of sign in and watch the program. With me also tonight is Meg Hufford, my colleague and fellow staff member in the EPO, which is Education and Public Outreach for the School of Earth and Space Exploration. We call ourselves the Community Outreach Group, and the initials for that mean cog. So we feel like we are cogs in the bigger wheel, I guess. But that's what we do. And a trusted and wonderful student that has been with us all along, Alex Blanche, is here tonight. I have to say, I'm sorry that Alicia was going to be here. You guys know, many of you know Alicia Hyatt. She has also been with the program a lot. Something at the last minute came up. She could not do our program tonight. So we had some plans. We're covering for her. She's sorry that she couldn't be here. And I'm sorry too, because she really is a wonderful addition to the program, but she has something going, and we'll let her do that as well. The other thing I wanted to do, just kind of right off the bat, well, let me get over some of the housekeeping things. This is a webinar format, and what that means is that we just kind of disable the chat. You can't chat with us in that sort of chat room, but you can communicate with us, and we're going to do this a couple of times tonight. I really encourage you to communicate in the question and answer button. So it's on your screen. You can press that one and you can put in a question, you can put in a comment or anything. And tonight, I really want to enable you and empower you to add comments, because what we're going to do is we're going to ask your opinion about some things here and again, especially in the middle of the show, about some of the things we should take into next year, some of the things you'd like to see more of, some of the things that you like about what we've done, or maybe an idea that we haven't even thought of yet. And so those things, this is really the night for us to do that. And so continuously through the program, if you think of something you want to see, think of something you want to comment about, go ahead and use that question and answer button. You can also use it for questions if you'd like, but that is our way to communicate. And we'll talk to you a little bit more about that later. We also use closed captioning. You probably noticed it. If you haven't, it's on your screen, and you can turn it off. It's up to you. You can watch it. You can not watch it. We put it on there because it helps us with the recordings. And when we post this on live later for people to watch later, it just happens to be there, and it works out very well for us. But you're in charge of that button, so you can turn it on or turn it off, the closed captioning. We also recommend that you use full screen for the presentation part of the program, and then usually the speaker will be in a little window. If there's multiple speakers, little windows off to the side, and you'll see how that works as we go forward. So with that said, I wanted to start something right off the bat. We're coming to the end of our year, we're getting ready for the spring. And one of the things we're getting ready to do is start engaging with K-12 schools. This is something we've done for years and years and years. Spring seems to be better for schools and teachers to visit our program and that kind of stuff. And I'm going to launch a poll real quick just to start off with. And it's very simple. All you have to do on the screen is just answer, are you an educator? We want to know if you're a teacher, if you're an educator, if you're in the K-12 school system, and if you're here and joining us, and that's what you are. So if you're not one, you don't have to answer this poll. I guess you could say no if you want to, but we do want to sort of just see how many educators might be with us, how many people that sort of teach our children are here. And then I'm also going to invite all of you, if you like what you see or if you want to communicate with us in the future. Kim has all of her communications tools online, and so if you have a question, if you want to bring your kids to our school, if you want to learn more about what it means to make a field trip, either on site or virtually, then we're going to kind of invite you to do that as well. All right. So the run of show is going to be, this is the last program in the year. We decided not to do one 2 weeks from now on December the 15th, and we really never had one scheduled for the end of the month. So really, we're going to use this as the sort of closeout of the year 2021. And that's why sort of the informal nature of this particular program and how we want to kind of chat with you about what you want us to do in the future years. We also, I'm going to spend the first half of the program, or nearly the first half of the program, just kind of talking about things that are happening right now, things that you can look for in the night sky between now and when we get together again in January. We're going to have quite a little break. So I'm going to kind of get you through the whole month, show you some things going on. We'll do a little planet watch and show you sort of like what to watch for with some of the planets and what they're going to do over the next 30 days, and maybe some of the stars and constellations. I also want to talk a little bit about the winter solstice and what that means and what it really means to have the longest night, the shortest day. And we're going to kind of talk a little bit about what that means about sunrises and sunsets and that kind of stuff. So that's the first half of the program. And then we'll take a break. We'll chat with you about programming ideas. And then really, we've taken some time to put together the top 10 things that we're looking forward to in 2012. So we're going to start that somewhere about midway in the program. And when it ends, we're done. We'll say goodbye and we'll say happy holidays, and then we'll move on. So that's a little bit it. It's a little bit different than our normal programming, but I think it's going to go pretty well. So so it looks like we have a handful of teachers with us. Thank you very, very much for coming. And I suspect if I asked that question, if you've ever been a teacher, that number would be a lot higher. But thank you. Thanks for your service in the classroom. And if you want to communicate with us later about how we can engage with your class in various ways, please let us know. I'm going to share screen now, and a little thing that we've been doing over the years, I kind of like it because it's kind of a pretty view. We use the technology of a program that we call SkyScan, which is something that we have in the Marston Theater on site. And when we start opening up for public programs, and when you can come back and visit us, you'll sort of see how this particular sort of program works on the big screen. One of the things that we developed several months ago, kind of just seemed to be something that really kind of helps us understand what's going on in the night sky, especially with the locations of the planets, is what I call Planet Watch. What you see here is your solar system. There it is. So you have 4 inner rocky planets and 4 outer gas giants. You can see all their orbits organized there. The blue one kind of towards the middle there, I'll go back in a minute, is the Earth. And so what I wanted to do is just show you this, because this is actually where all the planets are relative to each other in space right now. And one of the particular ways I like to teach, and I like to kind of get people to think about the sky, is there's something going on there. The planets are orbiting the sun, all of that stuff is happening in space. And there's part of that we get to see. And so there's a difference, though. You know, what's happening in space and what we get to see on Earth is different. I'm going to blow up those planets a little bit bigger so we can see what that looks like. Let's fly in just a little bit and sort of see here. There's the Earth. Get into the view here just a little bit further. I'm flying very gently tonight. And so what you see here on the screen, this is the Earth, that's you, and here we're in our orbit. We're actually moving this way over time. This is Venus right here, and it is also moving in its orbit. Because its orbit is closer to the sun than ours is, it's going to move a little faster than us. So if you want to think about these as like cars on a racetrack or something, we're about to be passed. Venus is moving this way. It's going to get in between us and the sun. And then I'm going to show you on another screen what your horizon looks like and what that's going to look like when you actually see it, right? And then if I just kind of slide over this way just a little bit, you see there's this Earth still in view. There's Venus, there's Jupiter and Saturn. And if you look at them in this order, let's see, can I move just to the side a little bit? Let me just try something here. And add moving wrong way, wrong way, wrong way. Let me just sort of like move over this way just a little bit. This is the order that we see them in the sky. So we see when you go out tonight, if you went out right now, you would see them. Jupiter, Saturn, and Venus are in the sky in this order. And you can see them sort of towards the south. I'm going to roll this just a little bit. And when you see it in the night sky, it's going to look a lot more like this, Jupiter will be a little higher and almost directly south, and it'll be the brightest object there. Saturn will be kind of a dusky, kind of reddish looking object right now, and it will be in the middle, right in between Saturn, and Venus will be unmistakable. It is absolutely the brightest thing in the sky next to the sun and the moon, and it'll be actually unmistakable. I also want to sort of show you something a little bit. See how Venus has a phase, just like a moon, right? So most of the light that is coming from the sun is shining on the other side of Venus. And so if you were to look at Venus through a telescope, it would look like a little moon. It would look like a crescent moon. Now, think this through for a second. Think with me a little bit. As it gets closer, as it gets more in a position in between us and the moon, or and the sun, what's going to happen is that little crescent shape is going to get thinner and thinner and thinner and thinner, but it's also going to start to get dimmer. So right now it's in one of these magical places where the size of Venus is really large because it's close to us, right? So we get a big sort of size angle, and that makes it brighter. But the sun is shining mostly on the other side, which makes it a little bit dimmer. And so that sort of the balance between those two, you just go out and check it out. You look at it tonight and you'll see how bright that is. Over the course of the next several weeks, Venus is going to move in its orbit, the Earth is going to move in its orbit, and I am going to do that for you right now. I'm just going to kind of move forward 30 days. Let me get it set up first. So I am going to 31 days. I'm going to move forward in 5 seconds, and here we go. Look at how much Jupiter is spinning. Okay, so 31 days, right? And Venus is now almost tucked right in there between us. We call that an inferior conjunction. That means Venus will pass between us and the sun. And when it gets closer and closer and closer to the sun, right, most of the light will be on the other side and the sun's glare will take over. And so really that means for you, during the next 31 days, Venus will be very, very bright for the next couple of weeks. And then I think you're going to see it get a little closer to the horizon, a little closer to the sun, a little dimmer, a little harder to see. And I'm going to guess, you'll have to check this out with me. I'm going to be watching. But what I wanted to do is kind of check box the last day I can see Venus this year. I'm thinking it's going to be somewhere around the 27th or 28th of December. I think that's when it's finally going to go. You got a good, nice view of the southwestern horizon. And let's just see. Let's check it out together. Let's see if I'm right. So I'm inviting you over the course of the next several weeks to just keep checking out the sky for sure. Check out those planets. Watch them. I'm going to just bring up another program here just so we can, because I like to do this kind of stuff. Now I'm going to show you what this looks like from the sky. So you've seen it from space, right? And now what we do is we get to see it as it looks from the sky itself. I just have to do a real quick thing here. Bam, bam. Lock this into place. And here we are. So now what you're looking at is sort of a planetarium program. And here's the sky that we were just talking about. Those three objects up there, let me just sort of show you real quick. I can take a little screenshot. This is going to be Jupiter right there. This is going to be Saturn right there. And this is going to be Venus right here. And you'll see that sort of here's the southern part of the sky. So Jupiter is very, very, very close to directly south right now. And that's where they are. Now, you might have been noticing, if you've been observing, if you're watching over the last several weeks, that Venus looks like it's getting closer to Saturn. And it actually is. So as we're doing our little sort of movement, right, the Earth is moving around and sort of orienting itself so that it's trying to get Venus in between us and Saturn. Venus is trying to get itself in between us and the sun. And that's essentially sort of how things are kind of shaping up. So if you've noticed that for a little bit, you're right. It has been. It appears to you that it's actually getting a little bit closer to the sun. I'm just going to move forward several days. So bump, 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 bump. There goes the moon. Bump, 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 bump. I'm going to go back to that moon in a minute. But as I walk through here, you see that? You see Venus is getting moving closer and closer to Saturn. But now watch what else is happening, right? The sun is going to start to set a little bit later in the evening, and Venus is going to start to set a little bit earlier in the evening. And so right about here, we're on January 3rd. Remember what I said? So, oops, I don't want to be up to the 1st of December. Let me go forward again. I think what we're going to find is somewhere around the 28th or something like that. Let me just move back a couple of minutes so you can see what's going on there. Let's get the sun back in that position. So the sun is just below the horizon. Venus is just above the horizon, but I think there's going to be enough glare. Venus will be close enough to in between us. So I'm just going to go out on a limb and I'm going to say that my bet for losing Venus into the glare of the sun, and it stops becoming one of our Western evening apparitions, is going to happen somewhere around the end of the month. And you can just sort of watch this whole thing sort out as we go. Let me go back to the beginning, because another fun thing I just really, really love to do, and you sort of saw it happening here a second ago, is to actually, so let me just move back again just after sunset. I'm going to go forward again a little bit and watch what happens to the moon. So here it comes. It is a new moon between the 3rd and the 4th. That means it's between us and the sun. You will probably be able to see it in the night sky somewhere around the 5th. And then on the 6th, it will sort of pass right by Venus. On the 7th, it'll pass right by Saturn. On the 8th, it'll pass right by Jupiter. So you'll be able to sort of see it just tick off those things. It won't look like this big, huge shape here. Let me see if I can fix that real quick. I might be able to. Solar system. With phases. Let's see if I can show you. There it is. So what you're seeing here is the moon backwards a little bit on Sunday night, this coming Sunday. You might be able to see a little tiny sliver. Let's see if you can. And then by the next night, it will be sort of conjuncting with Venus, with Saturn, with Jupiter. And then there you go. So that's that. Real quick, I'm just going to kind of show you. You remember a couple of weeks ago, we went over a huge part of the night sky. We were showing people Pegasus, the flying horse, the sea monster. We were doing Perseus and Algol, the demon eye. We're sort of like showing all of these. Just wanted to show you real quick something else going up in the nighttime sky, because before we see you again, we're going to have to say goodbye to some of these things. So over here, let's see if I can find it. There you go. There is a thing we call the summer triangle, right? And so this is Vega right here. This is Altair right here. And this is Deneb right here. Let me do that as a sort of just a real quick screenshot. And I'll show you why that makes a triangle. So Vega, oops, went the wrong direction, to Altair, to Deneb, and there it is. So it's still really prominent in the night sky, but just like Venus sinking into the sunset, the summer triangle is going to just sink closer and closer and closer to the horizon. And ultimately by about January or a little past January, we're going to lose this big asterism in the sky, the summer triangle. But for right now, look towards the west and look kind of high in the sky right after sunset, and you'll start to see that. Okay, I'm going to stop share here for just a second because I wanted to show you something else going on. And that's going to make me actually take a second here. And I'm going to call up a quick website. Sorry about that. Should have had this done before I go. It's called Time and Date. Phoenix is what I just sort of did here. And I just wanted to sort of show you how this works. Let me share this now. Sorry about this. I'm just taking a little bit longer than I usually do. I should have had this prepared beforehand. So in a little page here, and let me share it with you. And it's okay to use the internet for this kind of stuff, isn't it? It is for sure. So, let me just show you what's going on here. What we have here is, again, it's called time and date, and it's for Phoenix. I Googled just basically sunrise, sunset times to get this to come up. And I wanted to show you something funny going on that you might not know about. Over here on the side, what we have is all of the days in December. So here's today. It's going to show you sunrise, sunset. Everybody can see that, right? That's pretty easy. The length of day, right, over here. And then solar noon. I wanted to show you this one too. So we're going to kind of have a good look at sunrise, sunset times, and solar noon. And we're going to get kind of ready for the solstice. So the winter solstice is here on the 21st. Sunrise, sunset, length of day, and then solar noon. Remember that? Okay, so look at length of day here. That's the part I think everybody expects. I think everybody knows that the winter solstice is the shortest day of the year, the longest night of the year. It's when the sun is the most southern in its orbit, so that it's over the Tropic of Capricorn. And you can just read down through these things. You can see that, yeah, indeed, just by seconds, it is the shortest day. But look at these three: the day before, the day of, the day after. I mean, there's only 2 seconds difference between all of those numbers. So what solstice means in real terms is standstill. And so what we observe on the horizon is that wintertime, the sun moves south, 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 south as it sets in the sky, and then it sets at kind of its lowest point. But it tends to just hang there for a long time. And that's kind of important for us. And then after a while, it's just going to start moving back up and back up and back up again. And so that's kind of important to know. This makes sense. Winter solstice, 21st. Daylight length is the shortest daylight length of the entire year. You can see, you can read all the way up how the daylight length is more now. In January, it'll be more again. But watch what's going on here. Look at sunsets. And so the sunset tonight at 5:20. Tomorrow, 5:20. The next day, 5:20. The next day, 5:20, 5:20, 5:20, 5:20, 5:20. So you sort of get the picture here. For the next 9 days, sunset won't change at all. And then the sunsets start setting later. But why wouldn't we expect the earliest sunset to be on the day of the solstice? In fact, on the day of the solstice, the sun will set 4 minutes later than now. That doesn't make any sense to me, right? If it's the shortest day, why wouldn't it be the latest sunset and the earliest sunrise? And then do the same thing with sunrise. Look over here. 7:14. Yep. So this is getting later every single day. That means you have to sleep a little bit longer, or you have to get up a little bit earlier in the dark every day, every day, every day. But it continues to set a little bit later all the way into January. So the latest sunrise, the darkest morning, is actually January the 8th. Whereas the earliest sunset, the darkest evening, happens actually officially on December the 4th. But you can see that this isn't changing. What's the difference? Well, the difference is this, is that the moon, or the Earth, orbits the sun, and it orbits in an elliptical shape. And what that means is that, actually, I might be able to just call this up real quick. Let me see if I can do something. And what that means is that, that the Earth, cancel, hang on. If I can do this very, very quickly, I'll do it. If I can't, then again, I should have had all this done beforehand. Sorry about that. So I'm going to share another screen for you real quick so you can see what this looks like. And so this is sort of a little map of the Earth going around the sun. And you see it's an elliptical orbit. And you see over here, here's the solstice, the 21st, 22nd, and the Earth is kind of going over here. On January the 3rd, it's going to be at its closest approach. It's actually closer to the sun here. And then as it moves through the year, its orbit will take it a little bit farther away, called it's perihelion and aphelion. It means close to the sun, further from the sun. And there's not much difference, right? You're not going to notice it in sunlight and all that stuff. But what it does mean is that, and this is one of Kepler's laws, is that the Earth moves faster over here and changes position and sort of actually moves faster in its orbit. And then it slows down over here and moves slower in its orbit. And what that means is that the Earth sort of gets behind, right, up to about 15 minutes behind its solar noon in the beginning of December. And it makes up all that time during December and into January, and it goes about 15 minutes after the solar noon. So it actually catches up to itself and goes ahead. It changes in timing by 30 minutes over this little month. The effect of that to you is that's what makes that phenomenon happen, where the latest sunset, the earliest sunset and the latest sunrise do not match up to the winter solstice. They actually happen 2 weeks before and 2 weeks later. And the whole reason to that is the orbit of the Earth and its elliptical orbit around the sun. I know that's a really, really complicated answer to a really simple thing, but we notice it. I notice it, right? If you set your alarm clock and you get up at the same time every morning, you're noticing that over the next couple of weeks, you're going to get up in the dark more and more and more. But you might or might not notice that after the solstice, it gets even darker in the morning for another couple of weeks. And the opposite is true in the evening. So if you want your evening back, you're going to get it pretty soon. In about a week, we'll sort of end our 5:20 sunsets, and it'll start moving later and later and later. And that's something to look forward to. Two more things to think about in the month of December is there is a Geminid meteor shower. This particular one happens when there's a near full waxing moon. And I know we like to tell you on this program about these things. We do like to encourage you to get out and see these. This is actually a meteor shower that is kind of notable because it starts a little bit earlier in the evening. So on balance, we can have more moon to compete with, but you can start to see meteors in a serious way, like 10:30, 11, 12 at night. You don't have to wait until 2:33 or 4 in the morning. It is better later, and the moon will set, and it is better to sort of like do this at 2, 3, 4 in the morning. I'm not saying it isn't, but I'm going to encourage you to take your kids out and sort of check. This is the evenings of the 13th, 14th of December, the Geminids. And these are sort of some of the most, I call them powerful of meteorites. It's not the most ambitious as far as numbers, but the ones that you see tend to be a little brighter. The streaks are a little clearer, and it's a little easier to see. Okay, sorry for all the little fumbling and all that stuff, but the things to watch for this December is those planets. You'll see the change in the constellations. You'll see that the triangle get closer and closer to the western horizon before we see each other again in January. And then understanding what those planets are actually doing in space while you're watching them in the night sky is something that I think is important, and it's a really good way to learn about how the mechanics of all the system works. So those are the things to watch for. I am going to, did I stop share? So I'm not sharing anymore. I'm going to kind of invite the team to sort of like get ready because I wanted to do a little discussion. And if you want, Kim, if you wouldn't mind, we're just going to add a little slide to the screen just so you kind of just get the senses. And this is what I alluded to at the beginning of the show. But this is really a chance for you to just kind of think through some of the things you've seen on our program, some of the things that you'd like to see. If you want to use this opportunity to go into that question and answer button and just sort of say, I love watching, or you don't, or this is my first time, or have you guys ever done this, or we'd like to see more of this. This is actually the moment to do it. So if I've set this up correctly, you guys can start poking in there and just punch the question and answer button and just on your own, just kind of like type a little sort of like thing for us. We'll follow here for a little bit and watch what they're doing. Then I also wanted to say that there's another important thing coming up. You're going to hear about it right now because I'm going to tell you about the launch of an amazing spacecraft. And then you're going to hear about it a little bit later because the deployment of the spacecraft kind of falls into the things we're looking forward to in 2022. You've heard us talk a little bit about over the weeks about the James Webb Space Telescope. It's an amazing instrument. I'm not going to go too much into it tonight. Alex is going to give us a little briefing on the deployment here in a minute, but it's something we've been looking forward to. ASU has some time on the Space Telescope. Dr. Roger Windhorst, one of our Regents professors, has been working on this project for a decade or so. He's been one of the science advisors. We have many people on the cosmology team here at ASU that are sort of like really, really excited about this particular project in the James Webb. So right now, as it's scheduled, it will launch on December the 22nd. So that's going to happen before I see you again in January. I'm going to invite you to sort of like just join us for a virtual program. So what we're going to do, and here's the caveat, it's scheduled to launch at 5:20 in the morning. So we're going to be there. We're going to be bright-eyed. We're going to be awake. We're going to have our coffee, and we're going to be in the Marston Theater with a group filming and taping. We'll be able to interview Roger Windhorst and some of his team as they get ready for this thing. We'll be able to see the launch together, and so you will get an email from Kim, kind of going forward into December. We're going to kind of make it a little bit closer because these things tend to slip a little bit. This is one of those missions that doesn't have to launch in exactly the right time to be in the right position to go to a certain planet. Once it's deployed, it can happen anytime. So they will sort of slip these things sometime. Right now, we're thinking December the 22nd at 5:20 in the morning. And so we will send you a notice about when we're going to launch a broadcast, when we'll start talking about it. And if you want to get up that early, who knows? It'll be sort of one of the latest sunrises also. So it'll be very dark in the morning. Okay, there are a lot of things hitting the question and answer button. I'm just going to kind of read some of them myself. So here's something from Joanne. It's kind of an interesting thing. She's interested in maybe using telescopes on campus. This is something that we do. So when we can have public back, and we're anticipating that this will happen in the spring sometime, we're targeting late February for our first big public event. That one will be during a day, but several times during the semester, we do opportunities to deploy some telescopes, and we set them up on campus, and there's some students that know how to run them, and people can come up and visit us and kind of learn what we're looking at and take a peek through the telescope yourself. We have not been able to do that because of the pandemic up to this time, but we're looking forward to it. And I can tell you, I have some students that are just chomping at the bit to make this work. So we've got some really cool students that really want to take over this whole telescope program. And when they do, we'll have those things going. I think that is great. Here's the first time here. I thought it was super enjoyable. Good. Wait till the end of the show and see what happens. James Lyons, I think I know that name. So I would like to see more student time during each hour. Okay. I think that's probably a good idea. Native American constellation stories. This is really a good time to do that. So we will be trying to put together a visit and some stories for January. Some of you might already know that there's sort of in the culture, especially the ones that are here in the Southwest, wintertime is a good time to tell Native American stories. And we don't do it in the summertime. So we'll try to get, we'll definitely do some sort of Native American, North American cultural night program. We'll definitely get that put together for January or early February. I think we can do that. Oh, Joanne, I recognize your name here. We met Joanne up at Waste Thompson Arboretum. We did a little road show out there, and she's been visiting us ever since. Thanks, Joanne. Thanks for your comment. So Native American constellations again. People like that, Kim. We better sort of get something going here. So
I see a theme here.
Yeah, see how this works? This is really great, everybody. Thank you very much for doing this. I mean, sometimes when in our delivery system here, just by necessity, right, there's somebody that on the program, and we're sort of like pushing out, towards you guys. So we don't always get necessarily a chance to hear back from you, but this is really perfect. I'm so glad you're doing this. And I'm not going to spend much more time kind of doing all of them, but keep, if you think of something, just keep putting it in here. First time watcher, this is amazing. Thanks, Teresa. I love that stuff. Good. Yep. I see where we're going with this. Thank you, everybody, for doing this. And so I think what happens to us is we have people that sort of, lock in, and people that have been watching every other week. And we have people that sort of like join new, and that's really good. That's a good place for us to be. If you like this, kind of tell some friends. We also notice that we're getting people from across the country, and actually in some cases around the world. So that's really super cool. Another event I'm just going to announce, point you guys to. I've alluded to it a couple of times now, but ASU does this amazing event every single year, and we skipped last year for obvious reasons, but it's called Open Door. And the whole idea of this event is for people to be able to explore the university, but not actually on the surface level. This is a chance for people to kind of get in depth and into programs and meet people. Sometimes some of the gallery vaults will sort of like open their vaults so you can kind of see the inside. Some people open labs. Those kinds of things happen at Open Door. This year it is scheduled for February the 26th, and at least for now it's scheduled to be a public event. And so back to normal is the idea, and February 26th is the date. We're thinking, this is our current thinking, and so we're watching the pandemic very closely, so things can change on us, as you know, in a heartbeat, but we're watching very closely. And we're thinking about using that February the 26th date, the Open Door, to launch a series of public programs. We're going to go back to doing ticketed programs in the Marston Theater and some other things. You'll hear about this a little bit later, and Kim will elaborate a little bit. But so events coming up, watch for the James Webb Space Telescope, the launch on December the 22nd, and just kind of set your sights on February the 26th, because that is an ASU campus-wide extravaganza Open Door. And cross your fingers, right, that the pandemic treats us well, and we can do that. All right, it's that. So here's what I wanted to do next, and I will sort of introduce this idea one more time. What we thought to close out the year is to be forward-looking, is to like, so what are we looking forward to next year? What are the things that we can talk about at our show next year? What are the things that sort of like make us get excited about moving into 2022? And we tried to capture that in what we call the top 10, the 10 things that sort of are most important. And so then as a team, we're going to share these. So you will hear from all four of us. We'll all sort of like share, and we'll move from 10 to 1. And I'm just going to say this is sort of how we're going to end the program. So this will take a little while to get through 10 things. But at the end, we're not going to kind of come back and do any more programming. I'm just going to be able to say goodnight and wish you a holiday. So with that said, let's get started. I'm the first one and number 10, and I'll let him introduce his subject, but you're going to meet Alex Blanche.
Yes. Hi, everyone. Let me share my screen real quick. Hopefully you all can start to see that. Let's talk about something very near and dear to many hearts, mine included, James Webb Space Telescope.
I'll be darned. Hey, there's that name.
This is a very huge mission. This is a mission that's been literal decades in the making. I think the planning stages started before even I was born, and now it's launching where I'm in my 20s. So long mission and planning. It's had a very rocky journey to where it is now, but December 22nd, it will be launched. Some of you might have thought that it was December 18th. I wouldn't blame you. There was a small thing that went awry during transport, and they wanted to check to make sure that it was all set. So it got pushed a few days, but December 22nd, James Webb is launching on the Ariane 5 rocket, which you can see in that graphic, and it'll be traveling to its final resting stop of Lagrange point beyond the moon. And there it will be. It'll deploy its mirrors. It'll fold everything out. It'll deploy its large sun shield that'll keep it cool and the sun away from its very sensitive infrared instruments. And then it'll start taking some of the furthest pictures that we've ever seen in the universe. And that's just some of the data it'll be doing. It'll also be looking at exoplanets. It'll be the next big scientific instrument. It's the kind of spiritual successor to the Hubble Space Telescope, and even though Hubble's still going, this is the next step. So this will be the next advancement in kind of that space telescope science and data collection, and hopefully we'll be able to learn more about our universe, and we'll get to see some great images. So This is launching December 22nd of this year, 2021, but we won't actually get images until 2022. It takes about 6 months from when it launches for it to unfold, get in position, run tests, and then it'll start taking images, and that's when we'll start to see those first results. So the first images of James Webb are coming next year. So that's the 10th. Well, not in, I guess, any particular order, but that's one of the top 10. That is number 10 on what we're looking forward to next year in terms of space and Earth exploration.
And Alex, you didn't say, but I'll just add that Alex actually works in that team. So Windhorst has a cosmology lab, and Alex has self-selected to kind of put himself in there and join that kind of group. So he's got some special insight into this. So
I'm very excited for it. My heart's gonna be in my throat until at least December 23rd, but even it'll be in my throat until at least we start getting images from it.
Oh my gosh, and the amazing deployment of this thing and how it opens up. So when we get back with everybody in January, we'll just give you an update on what's happening, how it's working, and we'll give you kind of regular updates about this particular mission and that 6 to 7 months as it gets out to its position as space unfolds itself and starts delivering. So number 10, James Webb Space Telescope. I'm going to take number 9, and I'm just going to kind of share something you've already seen a little bit of tonight. What this is about is sort of the dance of the planets, sort of just like we've been doing this year. We're going to do something next year. And so I like to kind of like give everybody an overview of, as we go through, I like to talk to people about conjunctions. Conjunction is just a astronomy term for when something gets in the way of something else. So as I was describing earlier tonight, Venus is going to pass between us and the sun. It's an inferior conjunction, but there's a handful of them coming up, and I just looked ahead. And so listen to this, and on April 8th, Mars and Saturn will be in the way of each other. And so you can see them on the screen here. Here's Mars, here's Saturn. So what's going to have to happen, of course, is, well, let me just move forward to April. See if I can make that happen. The Earth is going to have to move around in its orbit. Far enough for, oops, I did days, not months. That's not going to work. And you can sort of see how that's happening. See how the moon is kind of Earth and Mars and Saturn are sort of aligning over here. And so then April 30th, Jupiter and Venus are going to get in the way of each other. On May 29th, Mars and Jupiter will happen. And there's this really funny thing where Mars does a triple conjunction. And that happens in February and March, where it actually gets it and Venus interact for a little bit. We'll be able to see all those things. A little bit of a warning here, though, for those that are evening people. I was showing you before how all these planets are dancing over on this side of the Earth-Sun relationship. This means evening, this means morning. So as we sort of get into the spring, all this fun we're watching as these planets are moving around through space and kind of like interacting with each other. In the early part of the year, that's going to be morning stuff. Later in the year, that will be evening stuff again, but we'll kind of keep people track of that. The other thing we'll keep track of is meteor showers. We know these things are going to happen. We know you're interested in these. And one of the things I do like to keep people aware of is those periodic events, not necessarily the sunrise, the sunset, the full moons, those kinds of things, but those periodic events that sort of just keep us sort of attached to a bigger, more complicated solar system than we might have otherwise known. So number 9 is planet watch and conjunctions and the phenomenon that happens in space on a periodic basis. I'm going to turn it over to, who's next? Meg Humphrey. I better stop sharing, huh?
Well, good evening, all. And I just want to put in for everybody, Rick, we really appreciate how you help us watch the dance of the planets. You just drive that thing like a boss. So thanks for that. The number 8 top 10 is the LunaMap mission. Let me share my screen. And LunaMap is a spacecraft that was built at ASU. It is a small spacecraft that's going to do very big science at the moon. And so it is a very small spacecraft, but its principal investigator is Craig Hardgrove. Craig, as a postdoc, proposed this mission to NASA and they accepted it. And now Professor Craig Hardgrove is the principal investigator of the Lunar Polar Hydrogen Mapper. This spacecraft will travel to the moon, and where other spacecraft, other larger spacecraft will, in their orbit, they could, on Mars, the spacecrafts that orbit are 190 miles above the surface, 200 miles, 250 miles above the surface. The LunaMap spacecraft will orbit the south pole of the moon at incredibly close distances between 4 and 12 kilometers. That's 5 and 7 miles or something like that. I got to get that down, but we appreciate that the LunaMap is going to help us determine the presence of hydrogen at the poles of the moon. And Craig has moved through. This spacecraft was built right here at ASU on the Tempe campus, and we're very happy about that. This is a picture of just some of the members of the team that make it happen. They are photographed on the Tempe campus on the crater carpet at ISTB-4. I want to go back in time just a little. Our second program of 2021, we were celebrating the 14th anniversary of the Apollo 14 mission. And we had a visit from some of our friends from the Lunar Reconnaissance Orbiter camera. And in addition, one of the LunaMap team members, Joe Dubois, joined us. And so I have shared a screenshot of Joe talking with Rick about the Lunar Hydrogen Polar Mapper. This is a picture of Joe in the clean lab on the first floor at ISTB-4. That space was very busy for a while, but it's not busy any longer because in July of 2021, the completion of the spacecraft was known. And I want to show you what it looks like when you pack up a small spacecraft. This is a few members of the team with the entire spacecraft in that suitcase. As opposed to big trucks that need to move it across the country, the principal investigator and a fellow team member strapped that in to a coach. Perhaps they were first class when they flew it from Phoenix to Florida. So LunaMap
I think I remember it was in the middle seat, right? So,
yes, it was in the middle seat and safe and sound. And we're very excited as we move forward to 2022 for the Lunar Polar Hydrogen Mapper mission. We know the launch window will open in February of 2022, and we look forward to sharing those updates with you. So number 8 of our top 10 is the LunaMap mission. And please note in the logo that the H is silent because it's the hydrogen that they're looking for on the south pole of the moon. And so our number 4 is the LunaMap mission, and we wish them well. And with that, I'm going to turn it over to our number 7. And who do we have?
It's me again. So I said at the beginning of our program that Alicia would really love to be here and be part of this particular program, but she was unable to. And so I'm going to take over this. Number 7, oops, I have lost control. Hang on one second. Number 7 then for us is, I'll just get it locked in here and get it shared. And here you go. Number 7 is we want you to enjoy Arizona. So Arizona State University and the School of Earth and Space Exploration is both the astronomical sciences and the geological sciences. I'm going to tell you, we live in an astronomy state. We live in a place where astronomy is celebrated at 4 universities now. We have observatories on top of mountains in Southern California, Lowell Observatory up in Flagstaff, and all in between. So it's really are an astronomy state, but it is one of the geologically most beautiful states in the Union. And so I want to suggest that in celebration of 2022, I want to invite everybody to just go visit Arizona, make it work. And so I've got a little geological map here to show you. I don't show any cities here, so you kind of watch my arrow. But for those of you that are new to the state or have never been introduced to some of the state geology, we divide the state into 3 geological regions, big regions. The Colorado Plateau is up here. So it has this sort of slanted thing. You can follow the line of Coconino County over here. That's pretty much the edge of the Colorado Plateau. And everything up in this corner is high and dry. And that's where we're going to find the Grand Canyon cut through there. Canyon de Chelly is absolutely gorgeous. Some of the Navajo lands, Monument Valley, the Batatican, and some of the Navajo National Monument, all of that stuff, Meteor Crater, all of this stuff, the top third of the state is absolutely worth visiting and wonderful. And the geology makes sense. And the geology is also cultural. So some people don't layer this on this, right? So we think of rocks, we think of geology, we think of these regions, but they are actually cultural regions as well. And the cultures that live there actually in the past, the Hopi, the Dene, they actually sort of melded themselves into the land. And you can see from their lifestyles, even today, you can see how they use the land and they mold to it, influenced by the geology of their place. In the southern half, this mostly green region out here is what we call basin and range. You can see little sort of mountains. They tend to go north-south over here. They sort of like tend to follow each other. This is a whole different area, and this is where we live. But in between, there is these other mountains, the transition zone, kind of crossing the whole state over here. And this is where the communities of like Payson and Sedona and Globe, Miami, and some of those places are. Also culturally significant. There's much trade going on. The Hohokam were down here, the O'odham down in this part of the state, using these dry, flat deserts, but there were people that sort of were moving goods, resources back and forth and up and down and around the state. You can investigate all of this. And so I know from our poll, people were interested in Native American culture and Native American sky stories, but Native Americans also have their land stories. And ASU and the School of Earth and Space Exploration is also a geological school. So I just wanted to sort of say, number 7, we're looking forward to promoting our state, getting you out there and see if we can see if we can explore together. All right, Alex, I think you're back.
I am back, and I've got kind of a combo resource and event. So 2022, I will actually bring some eclipses with it. So I'm going to talk about actually 2 of these. So we actually have 2 total lunar eclipses in 2022. We just had a partial one. You might have noted that it was the longest that we've had in North America in, I think, 600 or so years. But these are 2 total lunar eclipses. There's one in May, and then there's one in November. Timeanddate.com, this is a resource we've talked about a lot. This will be the place to go when you're trying to find out when and where you want to see this lunar eclipse. The first one in May is pretty close to the east coast of the United States, and where you can see the entire eclipse. So if you're on that east coast, good for you. But if you're not, then November's got you covered. We on the west coast are in the total dark red area of the entire eclipse. So 2 total lunar eclipses, one in May, one in November. Both of them are at least partially visible in the entire United States and in many other places across the world. But be sure to check out what time you can see this, either by using timeanddate.com or any other website that you get your eclipse info. But be sure to check these out because these are just wonderful events to watch and very exciting. So keep an eye out for those. And I think now we're moving on to our number 5, which is back to Rick again.
Oh my gosh, not me again. We didn't really plan this way, but I am handling some of Alicia's things. But let me introduce you. We actually sort of ended up with 4 space missions. So you learned a little bit about James Webb. You learned a little bit about Lunar Map, which is what Meg presented. I'm going to show you one more. It's actually a really, really exciting project. And I think you guys are going to like this. So I'm going to kind of share screen here. I'm going to make it full again. This one is called ShadowCam, and it's another lunar mission, but this one comes to us from a whole different kind of direction. This is actually a Korean space mission project. KPLO is the Korean Pathfinder Lunar Orbiter. It is South Korea's first effort to send anything to the moon. It's their first moon mission, and they've been building this spacecraft. It's supposed to be an orbiter, and it is supposed to have instruments on it that will help us understand the resources on the surface of the moon. Here's how we get involved. They picked 4 instruments for themselves, and so the Korean spacecraft has 4 Korean instruments, and they will be sort of mapping and understanding the geology of the surface. But they invited NASA to supply an instrument. NASA put out a call to everybody. What should we do? We had a payload, and we knew what the mission's goal was and how it's going to orbit the moon. Dr. Mark Robinson of ASU submitted. This happened about 6 years ago. I suppose the submission might have been even before that, but it was awarded. And so the concept is called ShadowCam. And what it does is it flies over the moon, and what you see on the screen here is what we call permanently shadowed regions, or PSRs. And that means these are deep craters at the South Pole or at the North Pole. The South Pole seems to have more of them, and these are craters that do not ever see the light of sun. The Earth is tilted by about 23.5 degrees. We know that, right? So we have seasons, and the sun shines on different parts at different times of the year. The moon doesn't. The moon actually tilts by about 1.5 degrees. So it's less than 2 degrees of tilt. And that means that there are places, top and bottom, where you're behind ridge lines or deep into craters where the sun never shines. And we know that these are loaded with things like water trapped as ice. In geochemistry speak, those are called volatiles. Anything that can kind of vaporize or turn to a gas is a volatile. And we think that this is a strategic missing knowledge, or a strategic knowledge gap, as NASA calls it. We need to understand these a little bit better. So Mark proposed to design ShadowCam. It's very much has legacy in the lunar reconnaissance orbiter that we've been running for about 12 years. There is a narrow angle camera on that particular craft. This is a copy of the optics, except the sensor, the detector at the end, the kind of the receiver camera part, is 800 times more powerful than what is on the lunar orbiter. And that means it can see in very, very, very dark light. It will be able to see just little sort of fringes of light. We will be looking for reflection and albedo, which is actually sort of the light that comes back out of these permanently shadowed regions, to see if we can determine how much of that is volatiles, how much of that is water, and how much of that is otherwise. This is what that camera looks like. Here it is on the tray over here. It's not very big. We weren't allowed much space on the South Korean spacecraft, but this is it, ShadowCam. Dr. Mark Robinson at ASU is the principal investigator. It was designed here, built in San Diego, shipped to Korea to be loaded onto a spacecraft. The spacecraft will then be shipped to Florida. It's actually launching out of Cape Canaveral, and that will be on August the 1st, 2022. So number 5, yet another space mission, yet another launch, and we're looking forward to the launch of ShadowCam.
Number 4. Number 4 is, it's not simple. It is to expect the unexpected. You know, we live on a very dynamic planet with its forces and its under the ocean, on the surface, in the skies. We interact with the planets, etc. And so as you greet each day in the new year, we hope that you will see all the possibilities, but know that we here at ASU and our subject matter experts are prepared to be on hand when these dynamic things happen. And so when you begin each day, we hope that it will begin with all the joy that you can find, but know that we're here to inform you about things that may happen on our Earth and in the skies. Our own Professor Ramon Aerosmith studies the rumblings of the Earth, the tectonic activity. We have other professors that are studying what's happening at the ocean's floor. Of course, our own Professor Patrick Young, an astrophysicist, is always on call for news items that happen in terms of meteorites or that type of thing. So please know that as we move into 2022, we hope that you will greet each day with joy, and we hope that at night you will join us to look at the stars and continue to do that on their own, because as Jack Johnson says, we really are, it's always to get better when we're together. So number 4. Let's move on to number 3.
And that'll be me. Yeah, let's see. Let me share my screen real quick. Oh gosh, here we go. Okay. We're going to talk about another mission that's very near and dear to all of our hearts here, I think, especially, and that's the Psyche Mission, Journey to a Metal World 2022. This is very important to us because the former director of the School of Earth and Space Exploration is actually the principal investigator for this mission, Dr. Lindy Elkin Stanton. She's been, she was a very popular director, and we all loved her here when she was here, but now she's the principal investigator for this mission, and a lot of ASU staff and students are with her in designing and supporting and, you know, getting this mission ready to do what it's supposed to do, which is journey to a metal world. So the mission's called Psyche. There's also an asteroid called 16 Psyche, and it is theorized to be this very dense metal asteroid, and it's theorized to be even further a remnant of an early planetary core, which formed our early solar system. And so we want to send the spacecraft Psyche to the asteroid Psyche, and we want to study it to better understand not only just asteroids in general, but also we think it might give us a better understanding into planetary cores and maybe how Earth's planetary core is, because we just can't pop down there and, you know, take a little sample. It's very deep, one, and it's very hot, so we can't really get down there, but this is kind of the next best thing. But this is a NASA ASU mission. ASU is heavily involved, of course, because of the principal investigator, Dr. Elkin Stanton, but also a lot of students and staff, like I mentioned, are also involved in the mission as well. And so it's a big partnership. In addition to that, it's not only ASU and NASA, there's also JPL. Here's a bunch of websites and social pages that you can find for the mission at NASA Psyche for Twitter, NASA Psyche at Facebook, and cc.asu.edu/Psyche is our own school's webpage for it. And here's part of the team. This is one of the full Psyche team. Let me see if I can find. I can't see Dr. Elkin Stanton in this picture. I can't pick her up, but this is part of the full Psyche team. A lot of people from a bunch of different institutions. Oh wait, I see her right there. There she is. I found her. I picked her out. But this is part of the full team, and you know, it's wonderful to see so many people working on such a project, and of course all of them are so impassioned about this, so it's really nice. And here's the name of all of them. You know, we have a lot of people from ASU, and we have a lot of people, you know, from JPL and MIT and Stanford, and this is a very, very collaborative mission. You may have seen some familiar names like Jim Bell. He worked on a lot of the Mars rover missions. He was the principal investigator for those. He's also on this mission as well, and he's working on the imagers. He's part of the PI for imagers, so very, very exciting. And he's actually the deputy PI for the mission as a whole as well, so very exciting. But that's part of the team. Now there's also a psyche.asu.edu webpage, and you can actually see a lot of videos and activities there, which I think are just wonderful little resources to look at. You have, there's like a paper model you can print out. You can see the actual spacecraft arrive at JPL. If you've ever been to the ISTB4 lobby, we have the video playing. There are a lot of videos talking about what goes into designing and planning a mission like this. And there's also a full online course where you can learn about the whole process that it took to get Psyche accepted as a NASA mission, and also the design stage from the perspective of engineers and PIs and everything. It's very exciting. So I'd recommend to check out this website in addition for the many others. And then, are you psyched for Psyche? There's a whole bunch of components of this. There's a Psyche-inspired capstone project. These, because missions, even though a lot of them we just consider, you know, engineers and scientists, artists are a big part of this. People have to make the graphics for this. You have people in web design that are doing this, but we also have art students that design art projects based on the concept of the Psyche mission. Again, if you've ever been to the Gallery of Scientific Exploration, there are student artworks like clocks and paintings and sculptures that are designed to represent the concept and ideas of the Psyche project. And so that's part of the getting psyched for Psyche. But Psyche is launching in 2022. It's a mission that we are very excited for. So fingers crossed, and we are all looking forward to that next year.
Thank you. And it's actually August, help me, Kim, is it August 22nd, we think, the launch date?
I know it's definitely August.
The launch opportunity window opens August 1st. So
okay, good.
On that, which will be one of the activities that we'll look forward to in 2022. And so for number 2, for our top 10 things in 2022 to look forward to, we are looking forward to the return of in-person events. And I really hope that everybody that lives in the area can make it down to our open door event on February 26th. And I will give you guys the link to that. And that's going to be our first in-person event when we return to campus for these. And then we'll have many other ones coming up. And I would suggest signing up for our newsletter so that you can stay informed. And you can also check our community engagement events page on the CC website, and I will give you the links to all of those. But without further ado, I'm going to pass it back to Rick, and just we look forward to having you guys come back and visit us, because we're really excited to welcome everybody back into our campus and partake in all of our activities and events. And with that, I'll stop sharing and give you the links. And Rick.
It's been a long time coming. My goodness sakes, who knew that this would be? I think by the time we open at Open Door, it will be almost 2 years. It will be a year and 11 months between sort of having the public back in our halls and visiting us in live. And so we're very, very much looking forward to it. And if that's part of what 2022 brings, then that is absolutely great. Well, we've covered 10 through 2. We've saved 1 for the end. And so I thank you guys very, very much for indulging us today. I'm sorry that we're not going to see you in December. This will be our last program of the year. We'll be back on January the 12th, and that is a Wednesday night, same time, 7 o'clock. And then that will launch a new series of every other Wednesday, and we'll cover that all the way through the spring. So note that even though we were going to have public programs back on campus, we are also basically keeping alive the virtual night sky, because we like you and we like the audience and we like the format, and we can do things here that we can't otherwise do on campus. So we're going to do both. With that, number 2 seems so important that I thought the entire team would do this one together.
Okay, everybody.
Number 1,
Number 1.
3, 2, 1. The world will keep on turning. The world will keep on turning.
The world will keep turning.
The world will keep turning.
And in spite of the pandemic, the politics, and the anxiety in our daily lives,
The moon, through its phases, will continue to grace our skies.
Or Earth will continue its journey around the sun.
And the seasons will be marked by our familiar constellations, each in their turn. And for those who choose to look, the universe will inspire as it has for millennia. Thank you very much. And everybody have a really happy holiday. We look forward to seeing you next year.
thank you, everyone.